So Parallel Works has been around for quite a long time. We're coming up on our 10th year here. And from the very beginning, our mission was to democratize HPC and specialized computing resources for end users, scientists, engineers, researchers. That's now evolving to the AI community, people building their own models, training models, deploying them into operations. Our mission has stayed the same that entire time. So what had inspired us? It came from this need for organizations to be able to access their computing resources more effectively, take advantage of them in ways that maybe using batch schedulers and command lines don't fully allow them to. And our job here is to try to broaden that adoption.
Yeah, the challenges that we encountered as being a medical school is we're just a medical school, and everyone who's there are either professors who are doctors or people studying to be doctors or postdocs, and these people are not computer engineers. So when they come to use the HPC system, they don't necessarily know how to use Linux, they don't necessarily know how to use schedulers, and we really needed a system that allowed us to get them self-service, point and click, get around all of the command line and so forth, so they can just do their work and not spend a lot of time learning all of that computer engineering.
Our software is called the Activate platform. It's been released in June, which was a culmination of a full rebuild of the entire stack of technology, really over the last 2 to 3 years. The features that it now has is really a few fold that aim to help organizations operationalize their computing programs, both cloud or on-prem. So one of the main capabilities is the ability to abstract the schedulers of these diverse computing resources away, which is really becoming more and more important as AI clusters come into the front line with organizations. Cloud computing and cloud HPC is caught up to a lot of the on-prem capability, and organizations are sliding those in. So this ability to be able to orchestrate computing tasks across on-prem resources, legacy infrastructure, batch schedulers, virtualized environments, move workloads into the cloud effectively, as well as adopt new computing technology and hardware such as GPU clusters, other specialized accelerators coming out. Quantum, 3 or 4 years from now, we're going to be having that same discussion then. That's the big one, abstracting the schedulers away to make it a unified interface to talk to the resources. Secondly, when organizations try to operationalize their cloud program specifically, doing that for fixed cost budgets is very difficult. The cloud gives you bills that are delayed. So if an organization starts running computing, you don't really know what you spent for 6, 8, 24 hours later. We run HPC workloads. They're very large. They can burn past an allocation in a matter of hours. So we've had to actually enforce cloud budgets at a 3-minute resolution. And that provides the organizations the ability to really put fixed budgets to their cloud spend.
For the Einstein College of Medicine, Activate is key to our success for our initiative, which is to lower the threshold of complexity so that people can use these complex resources without having to be an expert on how to use the system. So a lot of our interactive applications, which benefit from having the resources of HPC, can be difficult for someone to use. But with Activate, what happens is they have a simple GUI interface that in some cases is really very intuitive and allows them to be able to access these resources easily. So people using anything from a Jupyter notebook to MATLAB to Schrodinger, all of these tools that have an interactive interface benefit from being able to use the interface, the Activate interface.
Yeah, so our need is we actually have 2 different environments for HPC, which is common in anything related to healthcare. So we have just a regular environment that everybody uses, and then we have what we call the safe environment, which is for PHI, PII, so identifiable data or other sensitive data. So we have data that's entrusted to us that we cannot let outside the boundaries, and we have extra accounting, extra safeguards in place, and so we set up the Parallel Works environment in both of those so we can keep it separate. So people who are using things in this safe environment are then able to take advantage of the Activate product, and at the same time, if they don't have data that's, it's been de-identified or is model data, they can just use that. And then that way they have, in the one environment, they have full access to things like the internet, whereas in the restricted environment, of course, we do everything in terms of what would be required for people using medical data.
For us, the vision for Activate is about continuing the process of making the technology easier for people to access. Right, so conceptually, in HPC in particular, there's a huge community of people who are engaged in understanding how the technology works, right down to the networking level. And it seems to be able to really exploit the technology. You have to be a good practitioner of HPC. You have to really understand all the individual components. How does storage work? How does the compute work? How much RAM do I need? But what we're looking to do is to make this really simple. So somebody knows that they want to be able to leverage compute, but they don't necessarily want to know all the details. They don't need to be an expert. What they need to be able to do is their science, and they need to be able to solve their problems. They need to study their hypotheses. And so with the tool, what we're looking to achieve is that simplicity, to leverage beyond their regular computer, their laptop, something that's a lot more powerful. But to them, it's going to seem as though they're using their laptop. And I think that's really the advantage and the opportunity that we have with this, is to be able to simplify something that's actually quite complex. And making something very complicated simple is actually very hard to do. And that's one of the things that Parallelworks has achieved with this product, and something I'm really excited about.
I would say right now our platform is solving for the diversity of technologies that they have or are starting to have. So as they're bringing in batch schedulers or refreshing those, they're bringing in virtualized environments, they're layering in cloud, they're layering in GPU clusters. A few years it will be quantum and different infrastructures. Having to create a unified interface between these things for their end users to interact with is a very difficult challenge. Parallelworks has been designing for that problem for 10 years, being the interface to all these different scheduler and infrastructure types. So that's one big challenge we're solving for. Secondly, these locations that people are computing in are going beyond just a single sideload environment now. Kind of gone are the days of having a single data center and you put all your work in it or your infrastructure in it and have people interacting with that. What we're seeing is organizations moving to diverse and distant infrastructure. Data centers across the country, moving in cloud, maybe in a different region. They can't get the GPU capacity they need on a hyperscaler, so they need to go to some other specialized GPU provider. This distance challenge is something that we're solving for by, again, unifying the interface to the resources and allowing the end users to come in through a single pane. It looks and feels the same wherever you're running. So that's how I would describe that.